Good morning, students. Today we are going to learn about the angle subtended by a chord at different points in a circle. So what are the various angles subtended by a chord or an arc at different points in a circle? First, the next, perpendicular drawn from the center to a chord. So if we consider the chord AB, then we have to draw the perpendicular from center over the chord. Consider this point as P. Then we will observe that this angle is 90 degree and the chord get divided into two equal parts. That is AP is equals to PB. This we will prove. Then we have to draw equal chord and their distance from the center. Means what? What is the distance? Like one chord is considered this as 2 centimeter, then other also we have to draw the 2 centimeter. How the same equal chord can be drawn? That can be drawn by considering the perpendicular length. So this will be our third topic, then cyclic quadrilateral if the time permits. Regarding the basic terms related to this circle, like what is circle, what is center, what is chord, what is segment, what is major arc, what is minor arc, what is major segment, what is minor segment, what is major sector, minor sector, how they are identified, what is diameter, diameter is longest chord, exterior point, interior point, all those things we have already learned in our previous lecture. So if you have doubt, please go for that lecture. Okay, now today we are going to continue with the angle made by a chord. Students, circle we have learned. Circle is identified with the center and the radius and their circumference. So the distance or any point on the circumference or circular boundary is always fixed from the center and is equal to radius r. Then we have learned a chord. Chord is denoted by AB. It is the straight line segment. Then arc. But this AB, if we considering the circular boundary or part of the circumference, then it is the arc. Now coming for the angle subtended by a chord or arc mean the same thing, because students, whether we consider a circle with center O, consider an arc AB, then it is possible just to considering the arc AB, we can make the angle at center, means joining A to center O and B to center O, and we have learned that this way a sector is formed if we are joining at the center. But at the same time, it is also possible to join A to any point on the circumference. It will also make some angle. It is also possible to take the point anywhere like this one. It is the other angle. It is also possible to make the angle like this, passing through O, go to other and then join it, means the diameter. Okay, it is possible.
Passing through B.
Yes, it is also possible to start from the A, go to the other segment and join to B. It is like this. So these are the various angles which is formed by a chord. Whether we are considering the chord or even if we consider a circle and chord AB, join it, still the same kind of angle can be made. Join A to center O and O to B. This is the angle at the center. We can make the other angle like join A to point P on the circumference on the major sector or basically major segment. It is also making some angle. Obviously all these angles will be different. We may make or take any point on the minor segment at Q. This is also other angle. Okay, this way different kind of angles are formed. So here it is the arc AB, but here it is the chord AB. Here we are getting that if the AB arc and AB chord, if they are at the same point, means whatever the A and B, means in the same figure if we draw or join A to B, then whether we are considering the angle made by AB chord or arc AB mean the same thing. Considering the chord AB, it is always forming a triangle. Considering the arc at the center, it is forming a sector. But if the point is on the circumference, then it is not the sector, but still the angle is formed at their circumference. This point may be on the side of major sector or major segment, basically, like this is our major segment, or maybe on the side of minor segment. Okay, so these are the angles on the circle. This may be called as the point P, Q, S. So at point P, Q, S, the different angles are formed. So these are angle at circle. Circle or circumference. But if we consider the angle formed at O, so this is the angle at center. Angle at center of circle. And this angle may be formed by which one? The chord AB or the arc AB. By chord AB, or may be written as the arc AB, mean the same thing. Okay, because A and B are at the same point. So this way different angles are formed. Then what is the relation between the angle formed by a chord or an arc at the center and at the circumference? I will just write the relation. Detailed proof is not required for you. So write angle or relation between angles formed by a chord or even an arc also, or an arc. So here it is the angles, not the single angle we are considering. So a student, let us consider a circle with center O and chord AB. Or rather than chord, we may take the arc itself. That also doesn't affect the concept. Consider the center O, the point A, and the other one is point B. The same. Here we may consider this arc. Then what are the different angle formed that I had explained? So angle may be formed at the center. So join A to O and O to B. So one thing is that, so angle form at center. Let us denote this angle form at center by the symbol alpha. Okay. Another person may consider the angle formed at the circumference on the same side of the chord. Consider this angle as theta. A student, you should be careful. the angle alpha and theta is formed on the same side of the chord, means in the same segment. Be careful for that, otherwise the students are committing mistake. So let us write one by one before going to make it more complex. Let alpha be angle formed at center, and this is theta. Okay, denotation is our theta. Be angle on circumference. On same side of chord. Okay, student? On same side. What do we mean by on the same side, students? So please understand this once again. Here alpha and theta are on the same side. Here we can write alpha and theta on same side of chord. Or what we are observing? Here we can observe that this chord is dividing this circle into two segments. Then this alpha and theta are on the or are in the same segment. Okay, that is in same segment. This is important because the confusion arises from here itself. Now if we consider, say, why the same segment? What is the other term? A student, one may think that AB is a chord and one of you may draw one angle at one side. Say, consider this point as Q, and you are joining the center this way. Okay, means you are making the alpha angle at the center O, but making some angle. Now let us consider this angle as the beta. Are you getting? This is the symbol for beta. Student, write down the symbol that we are using, or mostly that we will use. It is called as alpha. Like the alphabet A, it is the first alphabet of Greek. Alpha, beta, gamma, zeta, kappa, lota. Like ABCD, there is in other language it is there. Like in Hindi, it is ka, kha, ga, gha. Like in Kannada, Indu, Adu, Udu, like that one. So similarly, these are the alphabets of Greek. So this is commonly used in mathematics for denoting the angle and other things. This B, keep in mind here it is open slightly and one of the end is longer. It is called as beta. Okay, and this 0 with cutting at the center, it is called as theta. It is not only this much, so many are there. If you are writing like this one 8 but one of the end is open, it is called as delta. A student, keep in mind these symbols are quite frequent. Okay, sometime the capital delta, like A, maybe a small a and capital A, this is also delta, but this is capital. This one. If you are writing the Y, but in chord fashion, it is called as gamma. Okay, it is, so these are the most commonly used symbol. There are many more, but at least these 5 or 6 you have to keep in mind because we will use this. So if we consider, now coming back to this figure where I was explaining this figure. Okay, where the chord AB is making the angle alpha at center and beta on the other side of this segment. How is this other side? A student, here you can observe that the center is on the major side, but the angle formed is on the minor side. So these are on the opposite side. One may also take this, say the theta is formed even on the major side, then this theta and beta are on opposite side. Okay, student? So here theta and beta, what are on the same side? Theta and alpha, they are on same side. Okay, student? But theta and beta are on opposite side or in opposite segment, opposite side of the chord, or even this alpha and beta are also on opposite side. So this is the meaning that the two angles are on the same side, then there is a relation that angle subtended at center is the twice of the angle subtended at their circumference. So keep in mind, then angle subtended at center. So whether it is angle subtended by the chord AB or the arc AB, mean the same thing, is twice of the angle subtended by the same chord or same arc. Okay, student, please do not change the arc, otherwise this relation will not hold good. So angle subtended at circumference, at boundary. Like here in this figure, I have denoted the chord AB, the angle at center is alpha at O, and angle at circumference at point P is theta. And the important thing is that they are on the same side. That is important. Okay? Then only we can write at the center the angle is bigger and it is double. So alpha is equals to twice of theta. That we need to keep in mind. Okay, student? So this is the relation. There is other way. Even rather than considering the chord AB, even if you are considering the arc AB, making an angle alpha at center, and consider the angle at circumference be theta at point P, still this relation hold good. Alpha is equals to twice of theta. Okay, student? So whether it is angle subtended by the arc AB at center and angle subtended by the same arc AB at circumference, then angle at the center is twice of the angle at the circumference. Or angle at the circumference is how much? Half of the angle at the center. Okay? Mean the same thing. Or even if we consider the chord AB, then the chord AB also subtend the angle at center, which is twice the angle subtended at their circumference. These are the things that we need to keep in mind. Or we may write this way also, is 1 by 2 of alpha. That is angle at circumference or boundary is half angle at center. Which one? For same chord or maybe the arc and on same side, that we need to consider. Okay, students? So this is important. So for this same chord on the same side, this relation. Now here we have drawn it very conveniently. So this is the first thing that we have learned. Second, for the arc even we have learned, the relation also hold good. There is another kind of drawing this figure where our students are getting confused. Students, if I consider my circle like this and my point A and B are here, then what will be the angle at the center O and angle on the same kind of segment or sector? A student, in this case, joining A to O and O to B, one angle form at the center, it appear you like this one, okay? And other one may think for this one, yes, it's good, but it is exactly same as the earlier one. So this is like our alpha, this is like our theta, okay? So here also alpha is equals to twice of theta.
Twice of theta.
Yeah, but many a time or in questions, the angle may be drawn like this. Now observe it carefully, how I am making the angle. So it is my center O. Consider the point A, the point B. This arc we are considering. But in question, it will be given like this. The O to B. Rather than the smaller angle, this time the bigger angle is given. This angle. And the point P is given to you at somewhere here. Or we may consider this as the alpha. But this is the figure. And you need to find this angle at P. So what is the angle at P that we want to know? Sorry. What is the angle at P that we have to understand? Students, so be careful. From the figure 3 and even 1 and 2, we have observed that the arc or the chord is making the angle on the same side. Same side means what? A student, I was explaining, from this chord AB, if you are looking this way, you are observing one angle form is this one. Moving ahead, you are getting the other angle form is this one. Coming to the first question even, or the first one, the angle made by this AB was, once you are moving forward, the angle alpha is formed, moving forward, the angle theta is formed. Okay, so in the same order it is, or on the same side. But for this figure, for the angle at the center, if you are considering the angle at point P, then you may have to move in upward direction like this one. So which angle at O we shall consider? The same upward direction. What is that angle? That angle will be your this angle, student. Okay, but if you are taking the angle like this one, it will become downward. Okay, so this consideration is wrong. So for such a question, you always have to consider the angle in same order or in same side. It simply means that. So students, here if we are denoting this angle as alpha, then this will be theta. then alpha is equals to twice of theta in this case. Okay, so be careful, do not use this way or this, do not get confused. So you have to observe the angle from the same side, or you have to just draw a line for the two angle and you have to observe it. Let me take one more example. Students, if it is given like this one, A and B, and the center is O, and this time this is the angle Q, which is theta. So at center, which angle we need to consider? Whether the smaller angle this one or the bigger angle this one, which angle need to be considered? Yes, student, for relating this theta. Yes, tell me quickly. For relating this theta, you have to observe that theta is in this direction, means moving downward. So I need to consider this angle. Okay. So this angle should be denoted by alpha here. Getting? Because it will be this one. Though this angle is bigger, because angle that we have learned may be your acute, maybe your straight, or maybe like this one, or even like this one. The other one is, students, we shall consider this one, this to this one. Okay, or you may write, or you may draw like this one also, this to this one, considering from here to here. All are the angle. This is the bigger angle or reflex angle, that kind of thing we have to consider. So at the center, we need to consider for the reflex angle if we are drawing or making the angle at their minor segment. So these are the things. So in this case also the relation hold good, but we shall understand it. Alpha is equals to twice of theta. But you must look from the same direction. Okay, here it is this one, then you do not consider this one, otherwise it will give you a wrong result. You should consider on the same side, means on in the same line, it will be that. Okay, students, so this way you should be careful while drawing the angle. Now let me take one question or few questions, or let me take few more explanation. Let us take the sixth one. Students, what are the various angle relation that is formed? That I want to write here. Consider a circle with center O. Consider arc A and B. Join it, or we may take the chord AB. So if we consider the angle theta is this one, then what will be the bigger angle? Can anyone tell me? What will be this angle? Yes, student, tell me quickly.
Yes,
Yeah.
sir.
So what is this angle marked in black? What is that? This value we are given with the angle theta, which is the acute one, which is the smaller angle at the center. Then what will be the bigger angle at the center?
Alpha.
Not denote by alpha, or let us denote it by alpha itself if you are getting confused with this symbol. So this is our alpha. Then what is this? Student, I am asking you a very simple thing, that if we consider a point, if this angle is 180 degree, what is this angle? Also 180 degree. Student, if you have one angle as the theta, or say let us consider this as 40 degree, what is this outer angle or reflex angle? How we are calculating? Tell me quickly. What is this outer angle or reflex angle? Everything you people have got it.
360.
Good. It is your 360 minus 40. It is our 320 degree. So it is our 320 degree. A student, I had already told you in last lecture that you please revise the concept of line and angles and triangle. Otherwise, this chapter becomes difficult for you, though it is the easiest. A student, so if one angle is alpha, then other angle will be our 360 minus alpha. It's so simple. Okay, it is this one. Now we are going to make the angle at the circumference. Okay, student? So consider one is this one. So join it to be. Consider this as the theta. Then obvious, which relation will hold good? Alpha means we have to look for the same side. Means if you are looking for this one or looking toward the theta, you have to move this way. So once you will meet with the first alpha, then you will meet with this theta. Therefore, the relation here is alpha is equals to twice of theta. It is one relation. Means at the center, it is double that of the circumference. It is one thing. Now, it may be like that. The other angle is given at your other segment. Consider the point Q in the minor segment. Consider this angle as beta or gamma or whatever the denotation we have used. So let me denote it by delta. This way. Then delta is related to which angle, students? Delta is equals to which relation? So the related angle you have to write. The related angle. We will learn later. Delta is also related to theta. Delta plus theta is 180 degree. That is called the cyclic quadrilateral. But considering the center, so related angle at center. What is that? Yeah, student. Tell me. I had
Alpha.
Delta is related to alpha. Be careful. I had told you, if we consider an arc or a chord which is making some angle and consider the angle is made at the smaller segment, at this time you are looking for this angle. At this time you have to look for this angle because these two will fall in the same line. So you need to look for the reflex angle. Okay, students? So you should be careful. Getting? So therefore, here, which two angles are related? Yes, student, tell me.
360 minus alpha.
Very good. So if the chord is even drawn like this, one of the angle is at the P point, another angle at the center O. Then I was talking or I was explaining that which angle at center need to be considered. Here we are considering the angle at P. Then in the same order you need to look. Okay, student, come downward. So the angle at this time you should look from this side, so that while you are moving from upward, the two angles will be in the same order. Okay, so this angle is related. Okay, so be careful for this. Or even for the arc, it can be drawn without joining the chord, also mean the same thing. So in this case, what we are observing, the angle on same side is, one is our delta, Then for this, the other one is 360 minus alpha. Okay, students, so be careful. It is related to this one. So in this case, we can write that the delta is how much? Delta is angle at the circumference. So twice of delta is equals to angle at the center, 360 minus of alpha. Okay, student? So this will be the relation. So this way you should be careful. At the center only one angle will be given and the other angle may be asked on the circumference. The circumference angle may be on the minor side or maybe on the major side. Okay, so be careful for that. So observe the angle on the same side, means in the same line while you are moving. That is the concept. So this is the first theorem, or whatever we have learned, that is called as the first theorem. So write down this first one clearly. Angle at center is double of the angle on the circumference. I think we have written this. Yeah. So student, it is the very first theorem that you need to keep in mind. Angle at the boundary is half of the angle on the chord, or you may write this as angle at center is double of angle at which one? So at the center first we are considering those angle at boundary. Both mean the same thing. Okay, it is this one. Now this is the important theorem that you need to keep in mind, or important that we need to apply in many of the question for getting the angle. There is other way or other theorem. So student, you can mark this as a theorem itself. So this is our first theorem, where we have learned angle at the center is double of the angle at the boundary. Now it is possible that the angle is formed on the same boundary by the same curve. So that condition we are going to learn. Means if we are considering a circle, the arc AB or the chord AB, for a moment I am not relating to the center, but I may take a point P on one side. Let us consider this angle as angle P. The other, this angle at Q. Other may take the angle here R. These are the angles. One may take this way also. From anywhere one may take. Then it is found that all these angles, PQRS or even point T, then it is found that all these angles PQRST are equal, provided they are on the same side. But it is also possible to draw like this one. Taking AB, now I am going to draw for a smaller segment. Yes, Valini, are you interested to ask something? You may ask. So the angle are like this one. These are the smaller angles. Okay, students? So these are the angles made at minor segment. In this case also the angle made is always equal. Means even whatever the angle at M, the same will be angle at N. So angle M is equals to angle N. Angle M is this angle, angle made is this. In this case, all the angle T is equals to angle P is equals to angle Q is equals to angle R. Angle T is equals to angle P is equals to angle S is equals to angle Q is equals to angle R. But the condition is that all these angles should be on the same side or in the same segment or on the same side of the chord. Here we cannot equate angle P is equals to angle M. Angle P cannot be equal to angle M. Okay, student? In fact, there is a relation that if we have the condition like this, consider A and B. Once you are making the angle P on one side, another angle M on the other side, in that angle P plus angle M, this value is 180 degrees. Okay, this we will learn later. It is the condition for cyclic quadrilateral. So students, we have learned the three things also for this one. That angle made on the same side of the chord on the boundaries are always equal among themselves. So that is the next theorem. So write down the theorem number 2. It is our, so be careful, the chord AB we are considering and the angle we are making on the boundary on the same side of the chord. So angle made on or subtended on same side of chord at the boundary are equal. It's so simple. Means you are free to choose either for the major sector. So all the angle made by the chord in their major sector, means for a specific chord, are equal. Or even you are also free to choose the angle made by this chord in their minor sector. So you have to choose only one kind of thing. That is the same thing. All the angles by chord AB in major side, in major segment, are equal. That is, angle T is equals to angle P is equals to angle S is equals to angle Q is equals to angle R. Okay, it is this one. Or we can also write this considering the minor segment. Also, all angles by chord AB in minor segment are equal. This is the second thing. That is, so come for this figure. Angle M is equals to angle N. If we are denoting it by some other angle, okay, then we can use that symbol also. Like if I am denoting it by θ1 and this by the θ2, then one may use the θ1 is equals to θ2. Okay, so these are the two important things, and these are the very two important theorems that we have to keep in mind. Note, write down one note. So for same chord AB, sum of the angle on opposite segment at their boundary is 180 degree. Sum of angles on opposite segment boundary is 180 degree. That is, you may use angle T plus angle M is 180 degree, or you can choose any pair. Okay, one from the major segment angle at boundary, you may take the Q, and still the other you may take as the M, also 180 degree, because all these T, Q, P, S, R are equal and M and N are equal. Or you may choose the other pair also, angle P plus angle M, or angle N can also be taken. So keep in mind, if the angle are on the opposite side of this chord AB, then their sum is 180. Okay, so these are the three important points that we need to keep in mind for the angle at their boundaries. Considering these two important theorem, we can go for the question and other understanding. Now, if we come for the semicircle, students, semicircle simply means the half circle. Then what is the angle by its diameter, or angle at their boundary? Angle at boundary. Basically, first we will understand what is the angle at center. This one. Student, we have learned that a semicircle means half of the circle. Means the center is somewhere here. So the other half, it is not done, it is neglected. Getting? So it is this one. In this case, we can observe that what will be the angle at the center, student? Can anyone tell me? The line passing through the center is the diameter, and it is a straight line. So what is the angle here? How much angle is it? Very good. It is our 180 degree. So if I am considering the point P anywhere here, what will be this angle? Yes, student, can you tell me?
180 minus theta.
180 minus theta. Where is that? I am asking for the angle at point P. Student, for that you need to use the relation that what is at the center, it is our alpha. Okay, since Angle at center alpha is twice of angle at the boundary, means twice of theta. Now alpha is a straight angle, so we can put in place of alpha as 180 degree, twice of theta. So what will be theta? 180 by 2 is equals to theta. So 90 degree value is theta. So theta is always 90 degree. Why? So angle at center is 180 degree, that you need to keep in mind. By this way, the angle at boundary is 90 degree. It is all, irrespective of where you are drawing. So we can quickly put like this. If we draw a circle with diameter AB, a student, what will be this angle? What will be this angle?
90.
Yeah, this angle is 180 degree. So half of this 90 degree. You draw anywhere. Consider this point as P. What will be this angle? Yes. What will be this angle, student? Is still 90 degree. That we have learned that on the same chord AB, because diameter is also like the longest chord, nothing else. The angle made on the same side is always equal. So wherever you are going to make any angle on the same side, that will always be your 90 degree. Okay, student? We can also take for the other side. Now let me come for this side. What will be this angle? Can anyone tell me? Student, what is this angle? Angle at the center on this side. Now you look. It is 180 degree. So from this side, it will be 90 degree.
90.
Okay. So be careful. So diameter always makes 90 degree at their boundary. So write that point also. So diameter subtends 90 degree at their boundary. On either side, because they are always equal. Here we are observing that 90 plus 90 can give us 180. So student, these are the few things that you need to keep in mind. You people are forgetting. Angle at boundary is always 90 degree. This I have shown with the help of calculation. So students, be careful. Do not forget this thing. So this was about the semicircle. Now let me take one question. The question are very simple. So find the missing angle. In figure. A student, a figure is given to you. Consider the point A, the point B, and one angle is like this one, and another angle is like this one. And this angle is your 60 degree. What is the missing angle? X in the first figure. In the second figure, so in the second figure, consider this is O and our point is like this one. AB is diameter because O is somewhere here. It is allocated. It is our Y. The second you have to tell for this one. Then third one, this is the third figure. Where the point A is here, the point B is here, and this angle is your 120 degree, and another one is this angle. Okay, consider this as your XY, say theta. This angle that we are considering is the angle theta. Okay, the missing angle. Yeah, tell me what is the value of X? Can anyone tell me quickly?
120.
Yes. What is the value
120.
of X?
120 degree.
Okay, some of you are saying at 120 degree. Let me draw one more figure for that. Let me consider A and B. In this case, this angle is our 45 degree. The other angle that I want to know is this one. What is this? Consider this as the alpha. So denotation can be anywhere for any angle. It is this one. Student, what we are observing from the first, you should be careful. Angle made by the same arc or same chord on the same side is always equal. So what is that condition here? Here our chord is AB, and we are observing that the angle is made on the same side. So the condition or the rule is which one? This one is the rule. For the same chord or for the same arc, the angle are always equal. So angle made on the same side of the chord or the arc is always equal. Angle made on same side of the chord. Are you getting? It is this one. At the boundary are equal. You people are forgetting. This I had explained right now. So this way, what we are observing, here we can observe that this point P and point Q are on the same side of the arc, okay, or on the same arc, same side of chord, or on the same arc. Which arc? It is the major arc. So here P and Q on same major arc AB, or on same chord you may consider AB if you are joining the AB by a dashed line. Therefore these two angles will be equal, students. I had just explained, no, on the same side whatever the angle made, they are always equal. So what is the condition? What is the value of X? Tell me quickly now. So X will be 60. It's so simple, student. So
60
therefore
degree.
X is equals to, or you may first write like this, angle P is same as angle Q, but angle P we are taking as X is equals to 60 degree. It's so simple, student. You people are getting confused. Now coming for the second one. What is the value of Y?
90 degree.
Good. So here it is our at the center, it is 180 degree because it is O, it is denoted. So it is at the boundary. So y is equals to 90 degree. As what is this? Semicircle, students. So on the either side, the angle will be equal, even if it is given on the other side, say beta, then this beta will also be your 90 degree, because these are the two angle on the boundary. O is given, it means it is the center. Students, these are very simple and asked in your MCQs, so you should be aware. Now coming to the figure 3, what will be the angle? Theta. Student, the same thing you have to apply whatever we have learned right
120
now.
degree.
Yes. So here again we are observing that these two are on the same arc. Getting? So therefore, same arc, which kind of arc is this? It is our minor arc. Therefore, we can write the theta is same as 120. Getting? So, or we may denote by putting some point M and N. So here M and N on same minor arc AB. Okay, student. So therefore, this angle M is equals to angle N. Angle M is 120 is equals to theta, or theta is equals to 120 degree. It's so simple kind. These are kind of questions are asked. This is based on this rule. Angle made on same side of the chord at the boundary chord, or same side of the arc, or this may be stated at angle on same arc from their ends are equal. This way we can also keep in mind. So both are the same thing. You have to just keep in mind. Like here, A to B major arc we have considered, and different P, T, Q, S, R are on the same boundary. So it is this one. So questions are very simple. Now coming to this fourth question. What is the value of alpha here? Center O is not there and they are on the same chord AB. What is the value of alpha? Good. So alpha is equals to 45 degree. The angle on
45 degree.
yes, chord AB. So whether it is considered for the chord or just leaving it looking for the arc, you will get the same result. The last question for today. Find the missing angle in following. So first one, consider a circle with AB as their chord, O as their center. Consider this as 120 degree. There is another point P where this angle is your theta or X. What is this one? This we will learn. In the second, we will learn for the A and B, the center O, At this time, this angle is given. Let us consider this angle as 100 degree. And then you need to find at point P what is this angle Y. Okay?
130. 130.
Okay, Y will be 130. Good. We will verify it. What is your Y? We will take the another example, another question. Let me draw like this. So consider the point A and B. And their center O is there. This angle is given. And this angle is what that we want to get. So let us take this as 100. Sorry, student, it is 200, not 100. Students, this is 200, because more, even take it 280, that will be better, that will appear you better. In the
So
second,
Y is equal to 80.
Yeah, 280, please make it like that. In this case,
40
it is
degree.
yeah, so 300 degree is this. The given reflex angle is your 300 degree. Are you getting what is this
Z is
300
equal to
degree?
30 degree.
Yes. Yes, sir. So it is our 300 degree. The fourth one, a student, you may be given the figure like this. Here, this angle is given as, consider 100 degree, and what is this angle? Consider at the theta. Okay, these are the questions that we have to do. Next theorem that we will learn, the angle joining the point on this and the center, that is dividing this into two equal part, that we will do tomorrow. So these are the things, questions that we have to do. Yeah, student, tell me what is the value of x and why is that?
60.
Yes, a student, since angle at center is equals to how much? Twice
Twice of the.
angle at boundary.
Yes, sir.
This relation we are going to use at the center O. What is the angle? The angle is 120, is equal
Degree.
to twice of at the boundary. We have denoted it by x. So x is equals to 120 by 2.
60.
Right.
60 degree.
So it is our 60 degree. It's so simple. Coming for this one, other one. How to apply
40.
the same theorem?
40 degree.
Yeah, student, be careful. In this case, what is y? Y is this one on the arc AB or the chord AB. So we need for this a smaller angle first. You first calculate this smaller angle. That will
80
be
degree.
the relation. So for this case, you may write angle
80 degree.
AOB should be equal to twice of angle AP.
APB.
Yes. Means the angle at the center. So angle at the center is not 280, but this will be how much? It will be 360 minus 100.
260 minus 280.
So this can be calculated by 360
Angle
minus
AOB
280.
80 degree.
Yes, is twice of y. Are you getting a student how I have written? Because at any point the total angle is 360. If this angle is even given as the x, then this angle can be calculated by 360 minus of x, irrespective of whether which appears better. Okay, so bigger angle is given here 280. So the smaller angle or the center angle that we have calculated is 360 minus 280. So just subtract it, it becomes 80 is
80
equal
degree
to 2y.
equal to 40 degree.
So y is equals to 40 degree. This division all of you are knowing, no? It will go for
Yes.
dividing the two. Good.
Yes.
Now coming to this one, again we are getting the same concept is also here, whatever in 2, but no chord is drawn,
40
even no marking is given, so you can just quickly mark. This become a 360
Z is equal to
minus
30
of
degree.
300 degree, it becomes 60 degree. Very good. So therefore, since 60 is equals to which one? Z.
2
So 2Z students. So
2Z.
be careful. Yes, it is our 2Z. So what is the value of Z? It is our 30
30
degree.
30 degree.
Are you getting? So the
Yes, sir.
same concept we had applied. Now come to this one. What will be for this angle theta? A student,
130.
theta is on the downward direction, so we need this bigger angle, their half. Okay. So therefore, what is this bigger angle? Bigger angle is our 300
360
minus
minus
100.
260.
Yeah.
Sir, 360.
Yeah, it is 360. So it is our 260.
260.
Okay.
130 is theta.
So here
130.
this bigger angle we need to take. Okay, so you are getting the angle must be in same order. So 260 should be equals to twice of theta. So
Theta equal
260
to
by 2 is equals to theta.
130.
So theta is equals to
130.
130 degree. Is it okay, student? So
Yes,
this
sir.
we have learned the very important theorem and important concept of calculating the angles. Based on this, the questions are framed,
Easy,
and
sir.
those questions are very important for you. A student, let us take our textbook question, or I hope you people can do which exercise you people can do.
Yes,
A student, see all these things I had explained yesterday. Where is that angle related? One entire exercise is there. Okay, the last one I had explained. Students, you can get this. So you have to solve this exercise. Students, you can get this question. I will solve this question
sir.
also, but you please try to solve it. Are you getting? The 100 is given, then what is the other angle? So just angle relation you can apply to get it.
Okay, sir.
So please solve these questions. Let me just copy it.
So which exercise?
Exercise 10.5.
10.5, question number 2, 3, 4, and 5. This thing we can solve. 2,
Okay,
3,
sir.
4, 5. Let me just copy it. Then I'm going to end it. Wait for 1 or 2 more minutes. So this is important point or important kind of concept based on which every year in all the examinations questions are asked. Okay. So question will be directly asked from this concept, students. So please do not forget. So do this homework. Our
Okay, sir.
exercise 10.5, question number 2 to 5. Only this much question you people can do. Okay, again you have to apply the same concept of triangle and angles, you can get it. And again our tomorrow at the same time our class will be there around 6:35 p.m. so you should be ready. Yeah, student, any doubt then please ask. And one thing more, it is observed that you people are not exactly getting all the things, so please go through the videos that I will upload today.